Hello, I'm an old guy and I do maths, and today we are going to graph another exponential function. This time we are graphing 2 to the negative x plus 2 plus 1, which you might see written like this: y equals 2 to the negative x plus 2 plus 1. And just a quick reminder of what basic exponential graphs look like. They have an asymptote at y equals 0. They pass through the y-axis at 0, 1 in their most basic form. They take off in the first quadrant of the Cartesian plane and head up here very quickly, and then they have a long tail out here that approaches but never reaches the x-axis. Okay, so let's get going with this. Now, because of this number here, it's a pretty safe bet that the asymptote on this graph has been raised from y equals 0 to y equals 1. But we'll go through the motions of making a few calculations and just seeing what this graph looks like. It is going to look quite a bit different, I suspect, to the one that you see in the bottom right-hand corner of the screen. Anyway, let's try some values. X equals 0. So if x equals 0, we get 2 to the power of 2. 0 plus 2 is 2 plus 1. So that gives us an interception point on the y-axis. So if x is 0, y is 2 squared plus 1. 5. 1, 2, 3, 4, 5. So it puts it about there. Right. Well, let's make x equal 1. So that means that we get 2 to the power of negative 1 plus 2. Negative 1 plus 2 is 2 to the power of 1 plus 1, sorry. So 2 to the power of 1 is 2, plus 1 is 3. So we get 1, 3. 1, 3. Interesting. 2 to the power, well, we'll make x equal 2. So that is 2 to the power of negative 2 plus 2. So that is 2 to the power of 0 plus 1. 2 to the power of 0 is 1. 1 plus 1 is 2. So at this point we are at 2, 2. And we can see a pattern emerging, I think. We'll go to x equals 3. And what we will get is 2 to the power of negative 3 plus 2, so that is 2 to the power of negative 1 plus 1. So at 3 we are about here, I would say. So that is 3. 2 to the power of negative 1 is a half, plus 1 is 3 on 2, or 1.5. And what you can see is that we're starting to get a turn in this direction, and we are approaching the asymptote as predicted. So there's our asymptote at y equals 1. And I'll put one more into here, just so that we can confirm what's going on. So that's 2 to the power of negative 4 plus 2, which is 2 to the power of negative 2 plus 1. 2 to the power of negative 2 is a quarter. And plus 1 is 1 1/4, so it is 5 over 4. And just forgive me, I'm going to go out of scale here, but this is 4, 5 on 4. And I hope, as you can see, that we are sort of leveling out, but we are running along and approaching the asymptote, but not getting near it. Now, what about over here? Well, I suspect we're going to have to extend our y-axis. So in this space over here, I'm going to put x equals negative 1. Now, what that means is that we've got 2 to the power of negative x, so that is actually 2 to the power of 1, plus 2, which equals 2 to the power of 3, which equals 8. So at negative 1, this thing has a value of, if this is, where are we, 1, 2, 3, 4, 5, if this is 5, 6, 7, 8, we're up here somewhere. And so what you can see is that the fact that we have a negative here has reflected this graph in the y-axis. So instead of, if I take a pencil, instead of looking something like that, this thing has been reflected across the y-axis, and this is the thing that has done it. Okay, in all other respects, it behaves just as a normal exponential graph. So again, what rules can we extract from this? Well, we've discovered that our asymptote is positive 1. What a surprise, that's there. The big thing, I think, is this, which, again, if we go back down to the bottom right of this screen, you'll see that the standard graph looks like this, and you can see how if we put in y equals a to the negative x, I hope you can read that, I'm writing in pen, I'll do it in pen, y equals a to the negative x would look like that. Okay, so that's the effect of this thing here. Well, thank you very much for watching. There will be more in this series, and there are things that you can learn from this that you can apply to logarithmic graphs, which are in another channel. Logarithms are separate on this channel. It's in another playlist. Sorry, logarithms are in a different playlist to this. Anyway, I hope this was informative. If it was, please like and subscribe, and I will see you in the next video. Thanks for watching. Bye.